Hey guys, welcome back to Geometry Summer Prep. We're going to jump into our lesson 6 today. Is it 6? Let's see. Yes, it's lesson 6. This one's all about angle relationships here, okay? So we're going to do what looks like a bunch of vocab notes, and that's actually true. Most of our notes today are just over vocabulary. So the first page, you'll see all this vocab. The meat of it is going to be this part right here. Really, really important vocab, okay? And then we're going to do on the second part of the notes, we're going to do a lot of like practical applications of this vocab. So it's really important vocab, and then we'll do the practical applications of it. And then you'll be able to go do in all of these practice problems, okay? And then you can jump over to the note video. Some of the practice problems are a little bit different, maybe even a little bit more challenging towards the end than the ones we're doing in the notes. So feel free to look at the practice problems video and work through some of them with me. Okay, let's dive into our notes here. So this top section, let's go ahead and do some of this fill in the blank stuff. This is a lot of notation with angles and some new stuff that you maybe didn't see. So first one says, an angle is formed by two, this blank here should say rays, with a common endpoint. And this may or may not be a word you've seen before in math, something called a ray. But let me explain what that is. So here is our example angle off to the side. So this is the angle, and it's made up of two rays. Here's a ray going this direction. Here's a ray going that direction, and they make up the angle. That's all that is saying. So if you want to do like a side thing out here, if you didn't know what a ray was, it's almost like a line, except it has one end point, and then it goes on forever in one direction. So that is called a ray. All right. And they have a common end point that we call the vertex of the angle. The vertex. So in this little example here, point B would be the vertex of this angle, okay? The rays are called the sides of the angle. Just so you know, when I'm throwing around these words, you know what I'm talking about. So the rays are the sides of the angle. And this is very important right here, knowing how to name an angle. So you name an angle using 3 letters. Let's just put a 3 right here, okay? And then an important part right here, it says the middle letter must always represent the vertex. So if I wanted to name this angle, and you can't just give it like any name that you want, you have to name it very specifically. I could call this either angle ABC, or I could go the other direction and call it angle CBA. But the order in which I say the 3 letters, the B has to be the center one. So let's actually name this angle over here. I would say this is angle. I would draw a little angle symbol, which looks like a less than, but it's an angle in this context. So angle ABC or angle CBA. And either one would be acceptable as long as the B is in the middle of it, okay? This part right here says use a single letter if there is only one angle located at the vertex. So actually in this example, I could also just call this angle B. Okay, so you could technically also call it, I'll just write it here, angle B. And that would be acceptable. You might be like, well, why do the 3 letters if I can just say angle B? You want to know how to do both, because what if it looked like, let me zoom in here a little bit. What if I extended this line like this? Okay, just go with me here. And let's say I put like another point on it. Let's just call it D because we haven't used that yet. And this were my picture. Well, you have multiple angles now. You've got the 60-degree angle and whatever this angle is. And you've got, if you want to look at it, you've got the whole thing as an entire angle. So if you just said angle B and this was your picture, I wouldn't know if you're talking about this angle B, or like the whole angle B. So it's really important you know how to name an angle using 3 letters, okay? So like if I wanted to name this angle, I could call it angle ABD, right? Or I could call it angle DBA. But I couldn't just say angle B in that context, if that makes sense. Okay, just wanted to be really thorough with you on that. And we have talked about this a little bit in the past. It says when referring to the measure of an angle, use a lowercase m. So m just means measure. So the measure of angle ABC, we would say equals 60 degrees in this picture. Okay, This part right here is a little bit of review, so you could probably answer these blanks yourself. This one will be new, but we might as well go through it together, but we have talked about this in previous lessons. So we do have different types of angles based on their angle measure. We know if it's less than 90 degrees, this is called an acute angle. Okay, if you want to put in parentheses, if this is new information, say less than 90 degrees. Okay, but we have talked about these before. This is an obtuse angle. Those are the big ones, obtuse. Obtuse, which means it's greater than 90 degrees. Greater than 90 degrees. And then this one is exactly 90 degrees, so we call it a right angle. I'll just put right. That's just exactly 90 degrees. And this one is weird, and you may be like, well, that's just a straight line. You're not wrong. We would call that a line. You can also call this a straight angle. I'm actually going to put the word angle on this one. A straight angle. Okay. And a straight angle, that might seem really obvious, but it's actually super important to this lesson that you know what that angle measure is, okay? If you just have a straight line, the measure of the angle, like from here to here, for instance, or I guess you could say from here to here, either way, any straight line measures 180 degrees. 180 degrees. Okay, but that concept of a straight line is going to come into play quite a bit. So let's go ahead and look down here at what I'm calling the meat of the notes. Let's start with, there's all these different ones. Let's see, 1, 2, 3, 4, 5 different big vocab words here, okay? So we're gonna go in kind of a specific order. Let's start with the one at the top, but y'all, these vocab words are super important. You will learn this pretty early on in geometry, but you will use it the rest of the year. So I have so many kids that even like halfway or even towards the end of the year, they hear these words and they still don't know what they mean, and it makes any other learning really, really difficult. So make sure you review these. Okay, the very first type of angle is called vertical angles, and it's a really simple concept that so many people just forget. So let's read through this. Vertical angles are created when you have two intersecting lines. I didn't read it, but it says two angles across from each other on intersecting lines. They are always congruent. If you want to underline that, always congruent. So let's draw a picture of this. So anytime you just have two random intersecting lines happening, so let's just draw boom, boom, two intersecting lines. And I'm going to draw the arrows on them to show that they are lines going on forever. Anytime you have two intersecting lines, you create vertical angles. You create two pair of these vertical angles. One of them is going to be like here and here. Okay, so we say those angles are vertical to each other. Okay, they're right across from each other, and they're always congruent. So let's give an example here. Let's just say this is 100 degrees. Well, you're going to automatically know the one across from it is also 100 degrees. Okay, you also have another pair of vertical angles. I'll do like a double arc mark to show that these ones are congruent to each other. Okay, and let's say this would be 80 degrees here, and if you know that's 80, this one's vertical to it. It's across from it, so it's also 80 degrees. Really big concept here, vertical angles. You will use this all year long. Okay, after vertical angles, let's talk about adjacent angles. And let's talk about what that word adjacent means. And they highlight it right here. They say this is the big part of it, right? Two angles that are next to each other and they share a common side. So I kind of use the example of like the word adjacent in general just means next to, right? Like the room I'm in right now is adjacent to the office next to me, right? Because we share a wall. This room and the office, we share a wall, okay? So it's just two angles that share a side, okay? So if I were to draw an example of this, I could draw so many different examples. Let's just go like this, and then, oops, not like that. Here, let's see. Okay, why is it doing that? Let's try again. Maybe I'll go this way and that way. And then I'll draw another angle like somewhere in the center of it, and I'm going to put my arrows on all of these. These are all rays. But notice I have two angles that I've created, right? I've got an angle right here. I've got a separate angle right here. And we would say those two angles are adjacent angles because they share this side right here, right? Here's an angle, there's an angle. They share that side, and that's it. They're adjacent. Nothing special about their measures. We just call them adjacent to each other. Let's actually jump down to supplementary angles after that. There's a reason I'm going in this order. Okay. Some of you may have learned supplementary and complementary in a previous math class. Most haven't, but some have. So these do have to do with their actual angle measures. So when we're talking about supplementary angles, those are just any two angles whose sum, like when you add them together, is 180 degrees. That's it. So there's a lot of ways you could draw an example picture here. Let's just draw two separate angles. Let me change that. Okay. Let's say I've got an angle right here, and I'll draw another angle. Well, here, let's label this one. Let's say this one is 110 degrees. All right, let's draw a separate angle out here. Let me draw my arrows on all of these. Okay, so this angle would have to be, doing the math, that'd have to be 70 degrees. Oh, there we go. 70 degrees because I want them to be supplementary, which means they have to add to 180. I didn't draw this. This shouldn't be leaning as much. It should really be running parallel to that, but you get the idea. These would add to 180, so they're supplementary angles. All right, after that, we're going to jump over here to linear pair for a very specific reason. Now, these are two angles that are both adjacent and supplementary, and they form a straight line. So this linear pair basically combines this concept with this concept. Okay, it's a combination of both of them. So try to think to yourself, like, how could you draw a picture where the angles are adjacent to each other and they're also supplementary? Think about what that picture would look like. Really, you can achieve that if you take this picture and you eliminate this gap in the middle right here. If you eliminate this part and you push those two angles together, they'll still be supplementary, but then they'll also be adjacent. Let me show you what that would look like up here. So I could redraw that 110 degree angle, okay, and then push the 70 degree angle right up next to it, just like that. So this would be the 70 degrees and this would be the 110 degrees. And you notice we have a nice straight line right here. Let's draw the arrows on all of these. So those would be what we call, they would form a linear pair because they're adjacent and they're supplementary. So special term, new word, new term, linear pair. There's a pair of them and they're on a straight line, linear pair. Okay, hopefully you got that. Last one here, and then we'll do some practice together. We have something called complementary angles, okay? So supplementary are angles that add to 180. Complementary are any two angles that add or whose sum is 90 degrees, okay? And they don't have to be adjacent. They can be. I'll draw them adjacent in this picture because it's just easiest to. So I would draw maybe like, I'd probably start with a little 90 degree angle here. So let me draw a right angle. And then let's say we have another angle inside of it, like over here, okay? And let's say this part of it is 60 degrees, which means this one would have to be 30 degrees. And those two angles we would say are complementary because they add up to 90 degrees. And that's it. Okay, so just some memorization you're gonna have to do. I don't expect you to have all of this memorized right now. This will take a while. But we're gonna use all those, so keep this handy while we look at the second part of the notes here. So now it's just practice stuff. Okay, 1 through 6, you're just checking off boxes. It says check all relationships between angles 1 and 2. So zooming in to 1 right here, you're given a picture with two angles and you have to check all the boxes that would apply. So if we look at this one, we have just two intersecting lines, so I know where this is going already, and they're telling us the ones across from each other are angles 1 and 2. So right away, I know those are vertical angles. That's just always what that's called. I think this is it for this one. We would not say they're adjacent, and that can be challenging for some people, but if you really highlight their angle, here's angle 1, right? So those are the 2 rays that make up that angle. And then here's angle 2, 2 separate rays that make up the angle. They don't share a common ray, so they're not adjacent. They don't say anything about their degree measures, so we don't know if they're complementary or supplementary. And they're not on a straight line, so they're not a linear pair. If angle 1 had been like right here, so if you had angle 1 there and angle 2 here, those would be on a straight line, so we then could say they do form a linear pair, which means they would also be supplementary, because that's part of a linear pair definition, and adjacent actually, but they don't have that on this one, so just vertical angles. All right, number 2, let's see what we have here. So here's my angle 1, here's my angle 2. These ones are adjacent. You can clearly tell they share a side of their angle. They're not vertical angles, so not that one. And we actually, even though they don't give us exact measures, this is key. They do tell us this is 90 degrees right here. And because this is a straight line, that actually forces this part to be 90 degrees, right? 90 and 90, you get the 180 degrees making up the line. So if this is 90 degrees, this is like the example we drew, angles 1 and 2 would have to be complementary because they'd have to add up to 90 degrees. So we'd say complementary. And they won't ever be complementary and supplementary, so you don't have to worry about that. That wouldn't make any sense, right? And of course, they're not a linear pair unless, well, the complementary will never be a linear pair because linear pair means they add to 180. Okay, hopefully you're getting the hang of this. If you want to pause it and try some of these and then play it and check them, go for it. All right, angles 1 and 2, that's kind of what we just talked about on the first one. They are adjacent because they share this ray right here, that side of their angles, right? They're not vertical because they're not across from each other. They're side by side. These would be supplementary and a linear pair. Oh, let me write that in blue. Supplementary and a linear pair because they do form a straight line. Okay, so they add to 180. Number 4, let's take a look at angles 1 and 2 here. They are adjacent, right? They definitely share a side right there. They are not vertical. They're not across from each other. How about their angle measures? We don't know. We don't see any 90-degree angles. This angle is definitely not a straight line, so this doesn't add up to 180. And they don't tell us if that's a right angle, so it's not a 90-degree angle. It's not complementary and not a linear pair, so that would be it, just adjacent. Okay, number 5. This one looks a little bit trickier. There's a lot of lines happening here, so let's dissect. So ultimately, I want you to first just look at these 2 lines intersecting. Boom, boom. Can you guys see that angle 1 and angle 2 are across from each other on those intersecting lines? That means they are vertical, okay? They're not adjacent. It's kind of like example 1, but a little more complex. They're not forming a straight line, so they're not going to be a linear pair. So let's see, can we decide complementary or supplementary from this picture? Well, you may not know some of this and what it means, but what they're trying to show you this and this are congruent. So this is congruent to that. I don't know if that's helpful, but we'll see here. They do give us that this angle is 90 degrees, okay? Now let me show you this because you can infer some things from that. If you have a straight line with a 90 degree on one side, that means this side is also a 90-degree angle, okay? And these little tick marks here show that these are congruent. So this whole angle is 90 degrees, and it's getting split in half, basically. That's what those blue marks are trying to show you. So if you split 90 degrees in half, that means I know this is actually a 45-degree angle, and this is a 45-degree angle. So I could actually say angle 1 is 45 degrees. I know that exact angle. This is a tricky one, which means it's vertical with 2, so 2 is also 45 degrees. And now think about it. What is the sum of those 2 angles? If you add them together, we get 90 degrees, right? I'm going to write this here. 45 degrees plus 45 degrees equals 90 degrees, which means they are complementary angles. That was a tricky one for sure, but hopefully you followed that. Okay, and number 6. Wait, was that it for that one? Yeah, that would be it for that one. Okay, number 6. Angles 1 and 2. Well, they're definitely vertical angles. They're not adjacent. They don't share a side. Do we know? They're not going to be a linear pair because they're not in a straight line. I think we can determine one other one though. Take a look at the 90-degree angle we have here. If this is 90, that means the one next to it has to be 90. And then if this is 90 degrees, the one across from it's also 90. In fact, all of these in the middle would be 90 degrees, okay? One of them being 90 will force all of them to be 90. So we could say angle 1 is 90 degrees. Angle 2 would also have to be the same because if they're vertical, they're always congruent. And 90 plus 90 is 180, which means they are supplementary. They add up to 180. I'm going to write that here. 90 degrees plus 90 degrees does equal 180 degrees. But they're not on a straight line, so we wouldn't actually say they form a linear pair. Okay, hopefully that went well. I know those last two were a little tricky. Let's look at our last little set of example problems, and then y'all can go try the practice. Okay, it says, find the missing measures in each figure, keep the angle relationships in mind. So this is how we're gonna actually use all the vocab we just learned. So number 1, they want you to find the missing angle, X, right? So on this one here, we have vertical angles, which means they are congruent. So this is a pretty simple one. X would equal 112 degrees. That's it. Okay, moving on. Number 2, they give me a 90-degree angle. They tell me one part of it is 68 degrees. So we have to find the missing part. So we're really just doing 90 minus 68, which would give us, let's see, 78, 88, what is that, 22 degrees? That would be your missing one. So these ones are pretty easy to start. Okay, how about this one? We do have a straight line. Always try to look out for those straight lines, which means these two added together has to equal 180. So really we're just doing 180, I'm just gonna throw out my calculator, minus 124, and I'll write it here, 180 minus 124. That's actually easy enough to do in your head. That would just be 56 degrees. Good, so those ones are pretty simple. Of course, they're gonna get a little bit more challenging. Number 4, we actually have 3 variables to find right here. Okay, so let's see, which one would be easiest to find first? Well, let's write off to the side. We wanna find X, Y, and Z. So I'm gonna make space for all of it. I would actually find Y first, because think about it. That one's just vertical with the 43-degree angle. So those we know are the same. So Y equals 43 degrees. Okay, now once we find either X or Z, we found them both because those are vertical to each other, so those are gonna be equal as well. So let's maybe look at, there's so many ways you could look at this. I always look for straight lines. So I'm gonna look at this straight line, we have a couple, and I'm gonna say, well, these ones are on a straight line, which means this angle and this angle have to add to 180. So to find X, I could just do 180 minus 43, which would give me 137 degrees. So that's gonna be your X, which also makes it your Z. 137 degrees, 137 degrees, and that's it. Good, so the ones with vertical angles are usually pretty easy. Let me box those. Okay, number 5, this one looks a little crazier. Again, we wanna find X, Y, and Z, so I'm gonna write that out to the side. X equals, Y equals, Z equals. Okay, if they give you a right angle, you can use that to do a lot of different things here. So if this is 90, and there's a lot of lines, so you really have to kind of think of them separately. So I'm gonna look at this line, and the fact that this is 90 means on this side also has to be 90 because those have to add to 180. So I'm gonna draw on a little 90-degree angle here, which means I can just do 90 minus this 72 degrees to get Z. So I'm actually gonna find Z first. So 90 minus 72 is gonna give us 18 degrees. I'm gonna write that over here. All right, so we know Z is 18 degrees. Okay, we still have to find X and Y. Now, just looking at those, they are on a straight line. So once I find one of them, I can do 180 minus it to find the other one. Let's maybe try to find X first. I don't know. This one is a little tricky. Okay, I actually can see, oh, you know what? No, let's find Y. Do y'all see the vertical angles here? Look at, kind of highlight the straight lines. Boom, there's a straight line. Boom, there's a straight line. If this right here is 72 degrees, then Y is also 72 degrees. So always look for your vertical angles. Super easy that way. I'm going to label this one as 72 degrees. So Y equals 72 degrees. And maybe you guys can see how you could find X from here, right? If those are supplementary, they add to 180. So we're going to do 180 minus 72. I'll write that here, which is going to give me 108 degrees, and that is going to give me X, 108 degrees. Okay, that one was a little bit challenging. A little multi-step. I kind of think they're really just like puzzles, so they're kind of fun. Let's try these last ones here. Lots of example problems, but your practice sheet is actually pretty short, so most of your work is going to happen in the notes today. All right, number 6. So they're giving us a description. Let's read through it. It says angle 1 and 2 are vertical angles. If the measure of angle 2 is 105, find the measure of angle 1. You could draw a picture, but this is pretty easy, y'all. Remember, if you have vertical angles, they are always across from each other. We could say this is angle 1, this is angle 2, but they're always equal. So if angle 2 is 105 degrees, so is angle 1. You really don't have to do any math there, 105 degrees. Okay, number 7. Angles A and B are complementary angles. If the measure of angle A is 42 degrees, find the measure of angle B. Well, we've talked about these. Complementary means they add to 90. So you're really just taking 90 and subtracting off 42, which will give me 48 degrees. And that's it. I just got to add up to 90, okay? Last couple problems. We've got angles P and Q are supplementary angles. So keep in mind what that means. That means they add to 180. And it says the measure of angle Q is 64. Find the measure of angle P. Again, you could draw a picture of this. You really don't need to. These are pretty simple. You're just going to be doing 180 minus 64 degrees, which gives us 116 degrees for that missing angle. Okay, last one. Angles 1 and 2 form a linear pair, which, you know what, we haven't done a ton of linear pairs, so you might want to draw a picture. A linear pair means you got just two angles going off of a straight line here. Okay, so we'll say here's angle 1, here's angle 2. It says if the measure of angle 1 is 113 degrees, 113 degrees, find the measure of angle 2. So think how you would do that. Well, linear pair means they are supplementary. So we're just going to do 180 minus 113. And it's totally fine if y'all use a calculator for all these computational things. Your teacher will most likely let you use one too. So angle 2 would have to equal 67 degrees. And that's it. Okay, so all the notes was pretty much vocab and then practice problems using the vocab. Let me pull this back up. So hopefully you followed that. There are a few on the practice sheet that are a little bit more challenging, so you might want to jump over that video and work through some of them with me. Good job, y'all.